Word of prayer. Father in heaven, we thank you. We bless and worship your holy name. You are good. You are awesome. You are a loving Father. Thank you for a time like this. Be thou exalted forever in Jesus' name. As we learn this morning, Lord, we receive excellent spirit from above and retentive capacity to the glory of your name. In Jesus' name we pray. Amen. All right, please take note F1. If you can hear me right now, please put on your video. I want to see your face and I want you to change the name of your device. Thank you. All right, last week. Okay, Balumi, are you raising up your hand? Balumi, you want to say something? It's all right. Last week we discussed something very interesting. We talked about digestive system. We talked about digestive system, and it was indeed a very interesting one. So today we will continue from where we stopped. Last week we couldn't finish it because of our time. So today we try as much as we can to meet up with time so that we can finish though we cannot still finish it today anyway. We can still finish it today. Hopefully, I don't know how true it is, but based on what I'm hearing, that you guys might likely come to school very soon. And that you might likely come to school very soon, maybe next week or so. I don't know how true that is, but I believe I've been hearing a lot of rumor up and down. But even before then, if you are going to be coming to school next week, or probably we will continue the remaining one when you come over. But now, let's just take our time to make sure that you get this topic very well. So, digestive system. So we looked at the alimentary canal, so we gave some definition. I gave some definition that last week. The digestive system comprises of all the parts of the body which aid the digestion and absorption of food in the body. This includes the alimentary canal, the organs, and some glands. So these are things that are responsible for digestion, or for digestion in the digestive system. So I said digestion is the breaking down of large food molecules such as carbohydrate, protein, fat, and etc. So when I mention breaking down, of course, you know from a layman English, when they say you break down something, meaning you break it down. As the English is, that is how it is. And you say you break down something, then you break it down, that's what it meant. Meaning, for example, you have big stuff, maybe big stones, and you want to break it down into smaller ones. So that's what it meant. Breaking down of large food substances or molecules such as carbohydrate, protein, fat, and etc. It doesn't matter how sweet the food you have eaten may taste in your mouth, it will still be broken down. Okay, it will still be broken down. So carbohydrate, proteins, fats, and whatever you have into smaller or absorbable particles with the aid of enzymes in the body and some organs or parts of the body. Now listen to this. I've explained this before now, but I'm still taking out my time to make sure I refresh your memory concerning this so that you can enjoy it better and you can understand it well. So I said it's broken down into unabsorbable particles. Absorbable simply means when you eat rice, for example, after you chew it for some time, you swallow it. Imagine how it's going to look like in your stomach when you get to your stomach. It's going to still remain like the way you chew it, not until after some time that the enzymes would have reacted on it. So when it's being broken down, it's not going to be like grinded more and make it finer, as you might be thinking. But what happens is it will grind it more anyway. If you have ever seen where they grind groundnut before, you have seen where they grind groundnut. By the time you grind groundnut, after some times, when you put, maybe if you start mixing it up, if you are mixing it, you want to make kuli, this groundnut cake from it. If you are mixing it, you discover that the groundnut oil, you'll be seeing the traces of groundnut oil on the surface, even without squeezing it yet. Just mixing it, you'll be seeing groundnut oil flowing around, little by little coming out. So when you eat food and it's broken down in your stomach into smaller particles in such a way that nutrients can be extracted from those food that you have eaten. So it's not going to get so that it can be transferred into your body system, into your bloodstream. That is where it will give you energy. And whatever things is present in the food that will give you whatever things you want, if it is fat, if it is protein, if it is carbohydrate. So that's how it's going to go into your body system. It's not going to go to your body system the way you chew it. It's going to be broken down, and it's going to be extracted. The nutrient out of it will be extracted, and the one that is not useful will be sent to the large intestine, and before you know it now, it comes out through your anus. All right, let's continue. The mouth. I said 3 things that is responsible for digestion of food in the mouth. We have the teeth, we have the salivary gland where saliva is produced, we have the tongue that rolls the food into a ball-like shape that passes it through your gullet or your esophagus. All right, so teeth, salivary gland, tongue, they are present in the mouth. What are they used for? They work together as a team to make sure that they achieve one goal. And what is that goal? To make sure that the food is able to be swallowed. That's just the purpose of the 3 of them. As the teeth is masticating it, the saliva from the salivary gland, that is the tylenine enzyme now, from the salivary gland, okay, react, or you mix with the food that you are chewing in your mouth, then tongue helps you to roll it up in the ball-like shape and pushes it down into your gullet. All right, so let's go on. The next one is the esophagus. So at the esophagus, I told you the other time, much things did not happen at the esophagus. Okay, what happened at the esophagus is just the movement. So esophagus is a link between the mouth and the stomach. Esophagus is a link between the mouth and the stomach. So when you finish chewing the food in your mouth and it's coming down, it passes through the gullet or the esophagus down to the stomach. So we see in the course of the proper notes, you will see the explanation in detail, then you get what I'm saying. So now the stomach, what is present in the stomach? I say HRP, that's what is present in the stomach, dilute hydrochloric acid. We have renin, it's an enzyme. We have pepsin, it's an enzyme. Then we have in the small intestine. I said the small intestine is divided into 3 forms. We have the duodenum, that's the first part of the small intestine. We have the jejunum, we have the ileum. Okay, so now looking at the duodenum, I say bile is part of the secretion that will be secreted on the food that also aid digestion. We have lipase, it's an enzyme. We have amylopsin, it's an enzyme. We have trypsin, also it's an enzyme. All these are in the duodenum. Now, in the ileum, we have sucrase, we have maltase, we have erepsin, we have lactate, and we have lipase. These ones too, all of these ones, they are enzymes. Then in the large intestine, like I told you the other time, much change did not really take place in the large intestine. One of the major things that's taking place in the large intestine is reabsorption of water, like I told you earlier. Now, the alimentary canal now proper. Okay, the alimentary canal proper now. So I said the alimentary canal is a large or long tube or vessel or column where the digestion and absorption of food takes place. I take it again. The alimentary canal is a large or long tube or vessel or column where the digestion and absorption of food takes place. So from your mouth down to your anus, the process of digestion takes place in between all these channels. This place, that is the process of, that's the alimentary canal, right? That is the places that are built or designed by God to permit absorption or digestion of food to take place. All right. So let's continue. The parts of alimentary canal now. I've told you 5 parts are involved in this digestive system or this alimentary canal, which aid digestion. We have number 1, the mouth. So as I'm mentioning them, the one that is also subdivided, in the mouth, the things that are contained in the mouth, we have the teeth, we have the salivary gland, we have the tongue. So just be imagining it as I'm mentioning it. I will not be mentioning the rest. The gullet, you know what happens in the gullet? The stomach, you know what takes place in the stomach, even if you don't know detail, we are going to explain it. The small intestine, you have an idea of what goes on in the small intestine, then in the large intestine. So all these 5 places, all these 5 stages, they are sequential. Okay, I cannot write, as my number 1 is the mouth, I can't put the stomach as number 2. That would be wrong of me. Meaning I've jumped the gullet. Digestion cannot take place that way. You can't just jump from the mouth to the stomach. It must follow through somewhere. So, and I cannot from the mouth straight to the large intestine. It will not work that way. So these 5, the way they are arranged, that is how they are in their stages and their processes. So this is a diagram that I displayed to you the other time. For example, for those of you that might not really know what duodenum is, look at this label, this U shape, this place that looks like a U shape. We call it roundabout. Okay, like I told you last week. I we call it roundabout. If you go to a restaurant and you say they should give you roundabout, okay, this is what they're going to give you. It's an intestinal organ. Okay, it's part of the small intestine. That's the first part of the small intestine. You see, it's labeled duodenum. It is U. It is the first place you meet immediately after the stomach. The first place immediately after the stomach. So that is the duodenum. So then you see this big one here. This big one is called the large intestine. Okay, that ends at the anus. Then this small one, this smaller one here, is called the small intestine, as the name implies. They look at their sizes. That is why they call them those names. Okay, so then what other things again is responsible? Of course, I told you last week, the sublingual gland, the submandibular gland. I said, especially this place, that is where the secretion of the saliva is from. And inside the saliva, we have the enzyme we call ptyalin, P-T-Y-A-L-I-N, ptyalin. Okay, ptyalin enzyme. That is responsible for the digestion of carbohydrate, especially starch. And I told you we have soft and hard palate. I told you if you touch your mouth, put your hand in your mouth, touch the upper part, the front part is the hard palate. Then when you touch the back is the soft palate, and so on and so forth. Okay, so this trachea and pharynx, this pharynx and trachea, they are not part of digestive system. Please, in this diagram, this one that you are seeing, this one that is color, is it light blue? This blue one, this one that is having branches here and here, they are not part of digestive system. The diagram just put it. It's not supposed to be there. Okay, those ones are exclusive for breathing. Okay, for breathing. That is where this particular one here, I'm coming, this one here. Can you see my cursor? I believe you can see my cursor, right?
Yes, sir.
Eh?
Yes, sir.
Okay. Yeah, this blue one here. That one is the pharynx or larynx. The pharynx is, or you call it the trachea, is the place where air follows into your lung. This one is connected to your nose. Okay, this one now is connected to your nose. It has nothing to do with food. There's something here. If you see this thing I'm touching here with my cursor, is called epiglottis. This thing you are seeing is called epiglottis. If you look at it carefully, you see it's resting on the track on the esophagus. This is the channel of the esophagus. This is the end of the mouth, at the airstream edge of the mouth. So its line is covering the entrance of the esophagus. What is the function of this epiglottis? It functions automatically. It's automatic in its function. Okay, it functions automatic. As I'm talking to you now, I cannot be breathing at the same time. It is not possible. If you are talking, try and talk and try to breathe at the same time, you'll be choked. It is not possible. It is after you must have finished speaking whatever thing you want to say from your mouth, that's when you breathe. So you cannot be breathing at the same time and talking, you'll be choked. That is why when you are talking, as I'm speaking to you right now, what is happening to me now is, you see the epiglottis, we open and cover where the food is going to, that is the esophagus now. Automatic. It will cover it, so that as I'm speaking to you, food cannot go in at the same time. I cannot be talking and swallow food at the same time. You'll be choked. So when you are eating and you are talking, when food is in your mouth, it can be dangerous. Because while you are talking and you are trying to swallow food at the same time, meaning you are trying to do multiple things at the same time. You are trying to swallow food, and as you are trying to swallow food, you are trying to breathe at the same time. So what happened there is the entrance of the trachea, okay, that is meant for air to go in and come out, will be open. And this epiglottis that works automatic, okay, you will confuse the epiglottis, because you confuse the epiglottis. Look at my hand. Let me quickly give you an illustration here. Okay, please make sure you are looking at me. Put on your videos, please. So look at this, my hand like this. This is a hole in my hand here. Are you watching me? This is a hole in my hand here. Okay, if I make it this way, if I do it this way, this my finger is the, okay, let me try to see if I can make two holes. Okay, this is one, this is two hole, this is one hole here, this is another hole here. Can you see this one hole, this one another hole? Let's assume that this first one is the trachea, where air is supposed to pass through into your lung. This first one here. This second one here is your esophagus, where food is supposed to enter. And this my finger here is the epiglottis. Okay, this my finger here is the epiglottis. And what is the function of the epiglottis? As I'm talking to you right now, okay, this is where food is supposed to enter. This epiglottis will cover this place. So this place will be open, okay? This other one will be open. This place will be covered. As soon as I finish talking and I want to breathe, it will open this place and cover this place quickly. When I finish breathing and I want to talk again, it will open and cover this place. That is how it's working. Okay? Automatic. You are not the one in charge. As I'm talking to you now, this one is covered and this one is open. If I want to stop talking, I want to relax a little, it will open. This will cover this one. As I finish. So when you are eating and you want to talk at the same time, okay? If you are eating and you want to talk at the same time, this thing will be walking up and jumping up and down like this. So, and peradventure, as you are trying to talk, and it will cover this place, and you are still talking, then it will open. Then food substance will enter into the trachea. If food particles enter into your trachea, then you start choking, start coughing. Until you cough it out from that place, that's when you have rest of mind. And imagine if the food that enters into the trachea goes deep down, that person will cough to death. You'll be choked because it will block where air will pass from the lung. It will block it. Then you see the person begin to be gasping for air. Then that will be the end of the person. Of course, if you cannot breathe in the next 5 minutes, you are gone. You are gone. So that is why it is very, very dangerous when you eat and you are trying to talk when there is food in your mouth. I know most of you do that a lot in the dining. Hey, give me my butter, give me my bottle, hey, give me my spoon. Okay. Give me my bottle, give me my spoon. Hey, stop that, I will slap you. All those noise is very dangerous when you do that. All right, that is by the way. So like I told you, this is not supposed to be part of the digestive system. But maybe because of this purpose, that is why it is put there so that I can remember and explain it to you, okay? So good, let's continue. To be, if I need this diagram, I will come back and explain to you. Now the mouth properly. So it won't be difficult for you to understand again. I've explained the bulk of the note. I said the mouth is the first part of the alimentary canal. It has some parts or structures inside it which help it to perform its functions. These are, we have the teeth, we have the salivary gland, we have the tongue. Okay, let's go on. I say when food is put into the mouth, that is when one eats. All these things I've explained before, but I'm just trying to read it out so that you guys just get it quickly. Okay, when one eats, the teeth helps to break down the large food into smaller bits or chunks. Okay, into smaller bits or chunks. So the chewing helps to masticate the food. The salivary glands secrete a digestive enzyme in form of water, in watery form, slightly alkali liquid called saliva. So in case they ask you, there's a slightly alkali substance that is secreted in the mouth. It's called dash, of course, saliva. Okay, so I say the saliva, which contains a special digestive enzyme called ptyalin, helps to soften or moisten the food. They also act on or convert carbohydrates or cooked starch into maltose. The maltose is also the same thing as complex sugar. Now, listen to me. So, the digestion of carbohydrate or starch, cooked starch, begins from the mouth. It didn't start in the stomach. Starch begins from the mouth. The digestion begins from the mouth. Protein did not start from the mouth. Digestion of protein starts in the stomach. Okay, but the digestion of starch begins from the mouth. Are you getting what I'm saying now? So now the one that is responsible for the conversion of carbohydrate now to maltose is the enzyme now, the ptyalin that I'm talking about. Then this enzyme is called amylase. The digestion of carbohydrates starts from the mouth. So the enzyme that is responsible to convert carbohydrate into maltose is called amylase. Amylase is the name of the enzyme that is responsible for the conversion of carbohydrate to maltose, that is complex sugar, is amylase. So like I told you, look at it here, digestion of carbohydrate or starts from the mouth. Let's go on. Oh, sorry. Okay. All right, sorry. I say the tongue helps to roll the broken food particles and also help to mix the food very well by its unsteady movement. Of course, you know that tongue doesn't stay in one place. While you are chewing food, it's jumping up and down. It's jumping up and down. Two of them, teeth and tongue, they are very good friends. So they used to help each other. As you are chewing, masticating the food, the tongue is doing its own work. As it's doing its own work, the saliva too is coming out and mixing the food, moistening it, making it soft, and all the necessary things are supposed to be carried out. So the purpose of the tongue is to roll the food, okay, and make it more convenient to swallow. So in a form called ball or bolus. At this stage, the food is set for the next part of the alimentary canal called the gullet. So now, once you are done chewing and masticating, it's ready for the next stage of their life. This is the gullet. Now, what happened in the gullet? The gullet or the oesophagus is the second part of the alimentary canal. It is lined with involuntary muscles which contract and relax rhythmically. When you see something is contracting and relaxing rhythmically, meaning in a rhythm. For example, if something is moving like this, okay, that's the rhythm. It's continuous. It will not do ke and do keke later. It will do like this. So if it's going through a particular movement, if it's coming, if it's moving like this, contracting, you see, that's rhythmically. It's involuntary, meaning you are not the one in charge, you are not the one controlling it. As long as food is going there, you're swallowing saliva, it's still saliva as food. Anything that passes through that place, that's not his business. You see them as food. So he just be doing his own movement. Not be doing his own movement. Okay? So digestion does not take place in the gullet. Of course, it won't be so smart of any individual to think, digestion is taking place in the gullet. No. So rather, the gullet serves as a passage for food from the mouth to the stomach by this movement we call peristalsis movement. Let's go on. So what is this peristalsis movement? I say peristalsis movement is the wave-like motion or movement of the involuntary muscles of the walls of the gullet. Remember, the gullet has a wall. That is the side, the surroundings of the gullet. So, which is caused by regular contraction. We have talked about regular contraction and relaxation. That is rhythmically, okay, of the muscles. The contraction and relaxation help to move the food in the gullet down to the stomach. So it is as a result of this rhythmic movement that helps it to move in that manner. In some cases, the food could also move up instead of down. And we talked about this the other time, and somebody mentioned, I asked a question, I said, what happens when this kind of things take place? Anti-peristalsis. And somebody say when you vomit. That's a very brilliant one there. That is exactly what happened. When you have anti-peristalsis, meaning the food that is supposed to be going to your stomach is now coming out of your stomach. That is anti-peristalsis. Okay? Let's go on, please. So now, the stomach now. The stomach. The stomach is the third part of the alimentary canal. It is a large sac-like organ in which the main digestion of food takes place. The main digestion, this is a big deal, okay? Big deal goes on in the stomach. A lot of activities goes on in the stomach, okay? It's like a sac-like. When you look at the diagram that I displayed to you the other time, it's like a sac-like in shape, and to contain the food substance that is coming, okay, from the mouth through the gullet or the esophagus. So sac-like organ in which the main digestion of food takes place. It has two valves. It has two valves, one at the top and the other at the bottom. Let me quickly show you the valve. Let me quickly show you the valve, quickly, from the diagram. Look at this is the valve. This is one entrance, that's one valve. This is another one, that's another valve here. That is, this one is the entrance of the stomach, and this one is leaving the stomach. Okay, this one is leaving the stomach. All right, let's go back to our notes very quickly. So, let's go on. So, what's going on here, man? So, I say it has two valves. That's the valve I've shown you now. One at the top and the other at the bottom. That's the top and the bottom of the stomach, which help to control the entrance and exit of food to and from the stomach, to the stomach and out of the stomach, respectively. So The walls of the stomach are lined with involuntary muscles and some digestive enzymes. Gastric juice produced by the gastric gland. Let's go on. I see under the stomach. So now the first one, that's the first valve now. When the food is coming from at the end of the gullet or the esophagus into the stomach, the first valve that we have there, we call it the cardiac sphincter. The cardiac sphincter. So this is the valve or ring of muscles at the top of the stomach, meaning at the entrance. What does it do? It opens and closes automatically. If I'm not eating, if I'm not swallowing saliva, if I'm only breathing, the place will be closed. It's just close like this. By the help of the muscle, to close like this. Look at it, just close. To close like this. But at the sense of food or saliva, anything coming to the stomach, it will open. As soon as it enters, it's closed. It opens. If you see food coming, it closes. If you see food coming again, it opens. Once the food enters, it closes. If another bolus is coming, another ball is coming, you are swallowing, it opens. It closes. So that is how it's working. Okay? Now, what happens in the stomach? The food is acted on by the following enzymes. After the food gets into your stomach, what happens there? Diluted hydrochloric acid neutralizes the alkaline nature that is coming from the saliva. Okay? It neutralizes it. Then there's a neutralizing reaction. Another thing that they do is when you probably swallow some things that are not palatable for your system, hydrochloric acid will help you to probably kill those bacteria. For example, if there's bacteria in your food in small quantity or not large quantity, and you eat them, you might feel some stomach pain. If you don't take any medication, some will go. But sometimes when it's becoming too big or too large for the hydrochloric acid to react upon, okay, it might not stop. So you might need to take drugs that will help you to boost the strength of your immune, that will put all this enzyme to action to strangulate or to kill any foreign substance in your stomach. So pepsin and renin, we'll be looking at what they will do in the stomach. These are produced by special cells lining the walls of the stomach. So all these ones, all these the dilute hydrochloric acid, pepsin, and renin, they are produced by the gastric juice. All right, the gastric juice in the stomach. The fruit from the mouth via the gullet is alkaline in nature. I've told you this. And since the enzymes in the stomach act only in the acidic medium, there is the need for conversion of the pH of the food from an alkaline medium to an acidic medium. We discussed pH the other time, and I know most of you must have studied the table I gave to you, the scale rather, concerning the pH value of a substance, how you get to know whether it is acidic, whether it is alkaline or basic, and whether it is neutral. So you know that. So to an acidic medium, the diluted hydrochloric acid, now look at it now, immediately stops the alkaline action of ptyalin in the food from the mouth. So as soon as the food gets into the stomach, the work of alkaline stops, it ends. The work of alkaline ends in the mouth. As soon as it's coming, once you get to the stomach, it ends. Acidic medium takes over. All right? So stop the action of ptyalin in the food from the mouth and changes from an alkaline medium to an acidic medium. The dilute hydrochloric acid also kills the germ or bacteria in the food, if any. Are you getting it now? If any, let's go on. Now that's hydrochloric acid, that is dilute hydrochloric acid. Then the pepsin. The pepsin, what they do is they act only on the protein. The pepsin act only on protein. You see, there is a division of labor in the stomach. Everybody knows his responsibility. Imagine in your classroom or in your house, if your parent has 3 children, and you say, okay, one of you will be washing plate, one of you will sweep, one of you will be cooking, doing the cooking. So when you wake up every day, you don't need anybody to come and tell you and say, hey, didn't I tell you that you're supposed to be washing plate? Hey, John, didn't I tell you that you're supposed to sweep? John, hey, Kemi, didn't I tell you that you're supposed to cook? Or Hadiza, didn't I tell you you're supposed to cook? You see, they are so unique in their way. Once food is coming, all of them, they rush. They go there. If it is protein will take its own. If it is this one will collect its own. If it is that, this one will select its own. They work on it. And they send it to where they are supposed to go to. Okay? In the conversion, they help in the conversion of whatever things. So if any, so pepsin acts on proteins in the food, if any, converting them to polypeptides. You know, the other time we say the conversion of carbohydrates, okay, to maltose. Okay, the conversion of carbohydrate to maltose is done by the help of amylase. Okay, you remember? Then the conversions of protein, all right, to polypeptide, okay, is done by this enzyme, pepsin, which is an intermediate product of the protein. So this polypeptide is an intermediate product of protein, between protein. So now the renin, we talked about the hydrochloric acid, dilute hydrochloric acid in the stomach, what its functions is. Then we talked about pepsin, that pepsin works on protein. Then now looking at renin, the renin is mostly needed by children than adults. Okay, the renin is mostly needed by children than adults. Why? Because it only acts on milk, if any. So you see, when you take milk as an adult, renin works for you. Okay, it's come and act on the coagulated milk or on the milk if you have taken anything milky. But you know, children, majorly their food is milk, the breast milk. And if it is not breast milk, if you give them the what do you call it now? The milk they give to children. Okay, the milk they made for children. So what I'm saying in essence is renin helps to act on the milk, in the stomach. Keziah, what are you doing with your system, for crying out loud? What are you pressing on your system? So coagulate, that is what renin does now. So you see, renin act on milk, pepsin act on protein, okay? Tyline act on starch or carbohydrate. You see them now, all of them have their own work. So the renin now coagulates the milk or convert it to thick cords and create a large surface area for enzyme action. Fume, what is going on there? Mute your device, please. Mute your device. All right. Excuse me. Fume, this boy. I say you should mute your device. You are distracting me. I don't like distraction.
Sorry.
No, Lord, I've muted. You have been muted here. Now, I say, so it coagulates the milk or convert it to a thick cord and create a large surface area for enzyme action. That is the action of pepsin on renin, on renin's product. So pepsin eventually reacts on renin's product because if you create a big surface, it's just like if you wash cloth now, for example, if you wash your towel, which one dries faster? Is it when you spread it or when you squeeze it and keep it in one place? Which one dries faster? I'm listening.
Sorry, when you spread it.
When you When you spread it, thank you. So meaning, you see, when the milk comes into the stomach and Renee acts on it, okay, it act on it and convert it and make it and give it a wider space and make it wide so that it can give room for quick action of other enzymes. Are you getting it now? For quick action. So the action of Renee helps to convert carcinogen. Now let's take it again. The action of Renee helps to convert carcinogen. What is carcinogen? An insoluble form of protein. An insoluble form of protein. Okay, Fumen, please, you opt out if you cannot hear me. Off your device. And come in again. Sorry, let me reply to Fumen. So carcinogen substance is an insoluble form of protein to casein. Now, the action of Renee helps to convert insoluble form of protein to a soluble form of protein, which can be acted on by pepsin. Do you get it now? So Renee also helps to convert carcinogen substance to casein substance, meaning an insoluble form of protein to a soluble form of protein. So you see, they help each other. Then by the time it helps to convert it to soluble form, then pepsin that acts on protein will now come in and act on it. You see the way they help each other. So it's just like if I tell the student to lie down, and the student, as I'm flogging the student, I say, I don't want to see your hand. I don't want your hand to touch your bum bum again. If you touch your bum bum, I will not flog you. I will wait until you remove your hand completely. And as I'm trying to pull the hands of the student away from the buttock so that I will flog him, he's pulling the hands back. But now tell somebody like Mr. Onoja or Ode to come and help me and hold the students. And of course, if it's someone like Akadi, for example, now, you know, he will just squeeze him under his armpit and hold his buttocks for me very well. So what is he doing for me? It's helping me to convert insoluble protein to soluble so that I can flog the soluble. Okay? And that is what pepsin, Renee and pepsin, that's what they do together. All right, let's go on. At this stage of digestion, the walls of what? The walls of the stomach wall undergoes a type of regular contraction and relaxation, which helps to further break down the food particles and mix it with the gastric juice until a paste-like or a thick creamy fluid or substance called chyme is formed. Some textbook, you will see it written CHYME. Don't be confused, it's still the same thing. It depends on the publisher. Okay, it depends on the publisher. It could be an American or it could be what do you call it now? British. Okay, CHIME and CHYME, they are the same thing. Don't be confused when you see it. Okay, here it's written CHIME. Maybe in the next slide you might see CHYME, and you'll be asking, sir, what is the difference between the two? They are the same thing. Okay, all right. So the stomach wall, it is not plain like this. The stomach wall is not plain like my hand. Okay, like my palm. It's not like this. It's not plain. How many of you have eaten what we call shaki before? As part of the meat, Yoruba people call it shaki. We call it towe inside the stomach of an animal. Good. If you have eaten shaki before, or see, if you have eaten shaki, you know what you are eating? You are eating the stomach of an animal. Because when you cut the stomach open and you turn it inside out, you will see some, especially the stomach of a cow, for example. If you turn it inside out, you will be seeing some dirty, you see remnant of the food leaves, you see all those nonsense and rubbish that it has eaten, soft mixed with water, like kind of, and dirty. So when you pour it away, when after you empty the stomach, you wash it with water very well. When you see the surface, you see your towel, the one you use to clean your body, the way the surface of your towel is, your towel is not always smooth. It's rough. That's rough surface. So standing like this, like in form of finger, like finger, tiny, tiny, tiny one like that, standing. Okay, that is how the wall. Somebody is telling me that it's also known as kayan chiki. Thank you. That is intestinal organ. Okay, in Hausa. Thank you. That is what they call it in Hausa. Thank you so much. For those of us that are familiar with the Hausa form. So, you see, that surface of the stomach is the one that is responsible as it's contracting and relaxing. Okay, it helps to further grind those food substances that you have eaten from your stomach, that you have eaten from your mouth, that enters your stomach. It's just be doing like this, as if it's grinding it. It will be grinding it. So as it's grinding it, the wall will be secreting some juice. Okay, applying it, making it look like, okay, I want to grind this now, make it smoother. All right. So into a paste that is called chyme. So when it is in the stomach, the process is called churning, like churning. It's churning. So making it smoother and turning it into chyme. All right, let's go on. So that by the time you keep grinding it, the nutrients will be coming out from the food substance that you have eaten. As it's grinding and making it smoother, the nutrients will be coming out. The nutrients will be coming out. All right. So our time is winding up. So the food time, you see what I said the other time, is spelled CHY here, ME. You see the same thing. The food now. So if I'm referring to the food now, I'm talking about the chyme, not the food in your mouth, the one in your stomach that has been churning. Okay, that has been churned. Stays in the stomach. Okay, for 3 to 4 hours. After which the involuntary muscles force the chyme through the lower valve. What did I call the upper valve the other time? Who can remember the upper valve? Yeah, Japheth. None of you can remember. I called the entrance into the stomach. I said we have 2 valves. One at the entrance and the other one leaving, exit. Is that it?
OESOPHAGUS.
Nope.
The cardiac sphincter.
The Lord bless your memory. Cardiac sphincter. So that's the first one. The entrance into the stomach. And by the time the food is churned and it's mixed properly and it wants to leave the stomach, you see, it will go through another valve. That valve is always closed, except if food wants to come out from the stomach into the small intestine. And that other valve, the second valve, that's the lower valve, is called pyloric sphincter. Pyloric. The first one is called cardiac sphincter, while the second one is called pyloric sphincter. Into the next part of the alimentary canal. And of course, which one is the next part of the alimentary canal?
Small intestine.
The small intestine. God bless you. You see what happens in the stomach? So we are done with the stomach and we are going into the small intestine. But my time is almost up. So the next teacher is ready to come up. So please, whatever happens in the course of the week, okay, whatever happens in the course of the week, let us stay safe. If you are resuming back to school, we will continue this. If you are not resuming, we will also still continue this. All right. So please take your time, go through the notes. Okay, I've not sent the note to you. Sorry, I will send it. I'm just taking my time to complete it. Okay, once it is done, once we are done with the note, I will forward everything so that when you are reading it and you attend this class, it will be very difficult for you to forget, except if you are not paying attention. What you have explained it so far, I trust God that God will expand it in your memory, in your heart, and you get a better knowledge of it. So anytime it's needed, whether in the question in the exam hall or anybody is asking you, to give to the person will not be very difficult for you in Jesus' name. So thank you for listening, and God bless you. Please stay safe, help your parents, learn how to cook if you don't know, and help your parents to do the home chore. God bless you in Jesus' name. Have a good day and stay safe once again. God bless you. Bye.
Bye.
Thank you.